before we continue, I think it's very important for us to take some time to better understand JavaScript asynchronous event handling. Now that's a mouthful, but asynchronous event handling is a huge part of not only JavaScript, but also the React ecosystem. Now, with ES6, there was promises that got introduced as a means of handling asynchronous events. We've already used them a little bit when we used fetch in our Monsters Rolodex project. But let's take a deeper dive into both fetch and promise, as well as the new ES7 syntax of async await. These are three things that we're going to use a lot in our application. So let's first look at what we had before promises so we could understand how promises work. Now, I've got some pseudocode here, but you can imagine what it is that this code is trying to do. We have some function called getUser, which fetches it from this link, right, of Facebook/Yihua. So we're fetching our Facebook user, Yihua. And then we give it this function, which is called a callback. Inside of it is either going to get the successfully retrieved user or an error if something goes wrong along the way. If there's an error, we want to throw the error, right? If there is no error, then we want to get the user ID and set it to this constant of user ID. And then we want to pass that into this new function, getFriends, where we give it the user ID, right? And maybe that fetches friends from whatever backend API it is, right? We don't really care. And then we give it also another callback. But this time, similar to what we just did with our getUser, it's either going to give us back our list of friends, or it's going to give us back an error if something goes wrong. We'll do the same thing, right? If it errors, we want to throw the error because we want to stop our code, right? If there is an error. And then we want to get our friend John from that list of friends if there is no error. We want to do some find, right? However it is that we get him. And then we want to get his posts in a similar method as the one before. We give posts, John, right? It gets it from whatever backend, and then we give it another callback. Posts, error, if error, throw the error, right? If there is no error, I want the first post, and then finally I want to get the comments for the post. Similar method, similar callback, before we finally end up displaying the comments. So this is as much of a mouthful to say as it is to read. Reading this code is really difficult because it's this massive pyramid tree-like shape of nested callbacks. And what we affectionately refer to this as is callback hell, because this code is extensively difficult to read and debug. Now, with the introduction of promises, its aim was to extrapolate out a lot of this stuff. And the reason for it is because this code here, these functions, are all asynchronous functions. We don't know when those functions will complete. And we have to nest a bunch of other function calls inside of each other because each one depends on the result and the return of the previous one. In order for us to get our friends, we need our user ID, which we get after we fetch it, right? And then in order to get the posts, we need to get our friend after we've gotten our friends list after we've gotten it from our user. Like, it's just this long, repetitive process, but this is also part of our coding. A lot of the times, this is what we'll need to do in order to eventually get that right final set of data we need. So Promises has simplified this, and Promises was introduced in ES6. So let's take a look at what it is. So let's get rid of this for now. Now, a promise is instantiated with this constructor. So we'll say const myPromise is equal to new promise, and then the promise is given a function. And in this function, it gets passed two things, a resolve and a reject. Now, what is the resolve and what is the reject? Well, a promise is kind of exactly as what it's named. It is a promise that this object will eventually have a value. It will either be a resolved value or a rejected value. The resolve value we use when our API call, for example, is successful. Our reject call we use when our API call gives us an error. But the promise will be in a state where it's pending until either the resolve or the reject has been called. Now, what does that mean? So let's say we have some set timeout. And set timeout is just this function that takes a callback and a time as its second argument. That time is in milliseconds. So we're saying after 1,000 milliseconds or 1 second, we want to run this function. And the function we want to run is resolve with the term I have succeeded. By doing this, we are saying that after 1 second, I want this promise to call the resolve key with this value of I have succeeded. So when this happens, when resolve finally gets called after 1 second, our promise now holds this value that we passed to the resolve. And in order for us to access it, we have to say my promise dot then, and then we pass the dot then a function where value will be the resolved value. So now we can finally console log the value. Now let's open up our terminal and run this in C. Let's say we run our code. We will see that after 1 second, it logged I have succeeded because our promise has resolved this value. Now reject will work in a similar way, except in how we end up accessing it. What we would do is, let's say we have some call where we say, let's say we have a conditional, and we'll just set this to true for now, right? If it's true, then we want to resolve our code. Otherwise, we want to reject with I have failed. Now, if we set our conditional to false, right, we will hit our else block and it will reject. And the only way for us in our promise code following the instantiation to access the rejected value is to chain on a dot catch. With the dot catch, we will get the reject value inside of the callback that we pass to it. So if we were to console log it, then now we will see we get the I have failed. So what we're getting with this promise is control over what we want to do with asynchronous events if they succeed or fail. Now, sometimes if we're just using set timeout, there's no reason to reject, and that's perfectly fine. If we just want to defer our promise's resolution, right, and we're using a set timeout, and there's no reason to reject, that's perfectly fine too. There's no need to call reject, right? We can only just resolve. But by having reject, we are able to control the separation of a successful API callback from an unsuccessful API callback. And that's the main benefit of using promises, is because when we make an API call, we don't know whether or not that'll work 100% of the time. If we call a server, we don't know if that server's down. We also don't know if we made a mistake in the parameters that we're passing in that API call. Let's say our backend is expecting a user ID, right? When you fetch at a certain endpoint. You don't give it the right server ID or you forget to give it an ID. Then that API call will throw you back with an error saying, that's not right. You didn't give me a user ID. Well, we want to handle that differently than we want to handle a successful API call. And that's why we have both this resolve and reject, because we're able to separate our concerns. Our success is in the then callback, and our failure, our error, is in the reject callback, which is in our catch. There's another thing that we can do with our promises. We're actually able to chain .thens together because the callback that we pass to it, whatever gets returned, right? In this case, we're returning console log, which actually doesn't return anything. It just returns undefined. But let's say we were to return our value, but we want to add a bunch of exclamation marks to it, right? So we're returning a new string plus 4 exclamation marks. What .then will do with that value is it will wrap it inside of a resolve promise. That way we can chain .then on it with our new value and then console log that new value, because the .then has wrapped this value in a resolved promise. You can only call .then on a resolved promise, right? You can't call it on a normal string, right? And the only reason we're able to do so is because each .then is wrapping the value that gets returned from the callback that they get passed in a resolved promise. Now, we can do this as many times as we want because every .then will be wrapping that return in a resolved promise. And we actually have seen promises before. If you're keen, this actually looks a lot like when we used fetch. If we look at this code, we see that fetch looks very similar to the promise code we just wrote. The reason for this is because fetch returns us a promise. When you call fetch, it's returning you a promise value while it makes an API request to the URL that you passed it. If the endpoint, for example, throws an error, like let's say we don't have the right permission to access it, or the server is down, or we misspelled the actual end URL. Well, instead of giving us back a value, fetch will actually also reject that value in the promise that it gives back to us. If it's successful, it instead will resolve it, which is how we're able to get a .then response, because that response is what that fetch gave us back. We convert it to a JSON object, right, by calling .json on response. And as I mentioned before, it ends up wrapping that JSON value in another resolve promise, which it then passes to the next .then, which we then finally console log. So if we were to look, that's what's happening here. That first promise is what gets returned from the fetch, a pending promise, right? Because it's not resolved or rejected. But once that comes back, it's successful, it resolves it internally, and then the .then gets called because it resolved. If we were to say, mess up this URL, right? So now we know it's false, right? If we did a catch instead, let's not console log the error because the error is quite ugly. You can imagine we do whatever we want with the error, right? But I'm just gonna console log the string I have errored. If we run this, we'll see that the I have errored string was the one that got console logged because the .catch occurred, right? Because the get call from our fetch failed and it came back with an error, and internally fetch rejected that error on our promise object. Now, while the chaining of our promises is rather easy, there is a little bit of complexity when it comes to figuring out how to structure our actual promise wrapping. The good news is that with ES7, there was a new function that was introduced called async await that allows us to better handle how we write our asynchronous code. So let's take a look at that now.